Well, I would like to welcome Ville Toulos. Ville trained his first neural network at the age of 13 and since then studied computer science, math, psychology, all in pursuit of making machine learning usable in real life. He started doing machine learning professionally in the early 2000s and has since worked in academia and startups, big companies. He's worked a lot with building infrastructure for data scientists. Specifically, he spent 4 years at Netflix, where he and the team that he was working with built Metaflow, um, which I'm sure we will talk about a lot. And I talked to some of his colleagues there, and they tell me that Ville has a very deep empathy for data scientists that is born from technical depth in ML and systems, and a keen ability to get to the heart of user needs. And then he can, and then he has an amazing product sense also, where he can translate those needs into delightful user experiences that seem like magic to the users. And so it's terrific to have him. He, since leaving Netflix, he is now a CEO of Outer Bounds. And Ville, would love to hear a little bit from you, not necessarily about like hop by hop what your career was, but like what were the key moments? What did you learn? And why did you end up in Outer Bounds? Clearly, you care enough about it to have left a job at Netflix that most people would probably never leave.
Right.
So, what was it about that attracted you?
Yeah, awesome. Well, I mean, thanks for having me. Um, yeah, well, I mean, maybe like a starting from the beginning, and I do have to say that now, especially with the latest AI boom, I've been thinking a lot, though, like also like what has happened over the past, I don't know, like 25 years or so, and it is a fact that I actually it's kind of amazing to say it, but I worked at my first like neural network startup like in 2000, so a long time ago. And of course, I mean, like for many people now, it's always easy to forget that like AI has existed, ML has existed, even neural networks, backpropagation, all of that has existed for a long time, right? And now, and of course it's really like easy to have like a fun to have this thought exercise that, let's say, like had I like stayed and like just kept working on, let's say, the neural network thing like kind of for 25 years, what would have happened? And it's actually like I'm pretty convinced that like I don't think that I would be in any better spot, which is actually kind of sad. But I mean, going back to the early days, I think like when then this is overall like a question of like how this like a technological like almost like a paradigm shifts play out. Is that the hard thing is that like, well, I mean, first, nobody knew what they're doing back then, like, and there was absolutely like a no demand. I mean, the biggest challenge I remember that when we tried to sell, and actually like it's quite amazing that the things that we were selling back then like were in many ways like a really quite similar conceptually. Of course, I mean, they really didn't work like even 1% as well as the models today, but we tried to sell basically this idea of a statistical neural network based, content based information retrieval systems. And then we had like all these beautiful demos and so forth. And then like people were asking that, can we do Boolean search? And then because that was the kind of the state of the art at the time. I mean, like kind of early days of the web. I mean, like it would have been amazing to have a text box where you can type a Boolean like a this and that. And people couldn't even imagine that, like, well, I mean, you can have like a natural language query. That was just like a way beyond in the future. So I think like a big lesson here is that like the timing is everything. It's really problematic to be too early, and that's why I mean these things are quite sensitive. So anyway, like a fast forward then, like, well, I guess there are like many things I could say about the whole like a smartphone thing that I was part of like for a good number of years. But I mean, even in that industry, then like I had this idea that, look, I mean, phones will be amazing devices for collecting data of different kind. Nokia, as some of you may remember, like was really a leading manufacturer of even camera phones. There was a lot of new data, unstructured data coming in, and people had all these ideas of applying computer vision, like amazing things that one could do. And all of these things ended up happening, unfortunately, by other companies than Nokia. But I mean, like people did have the foresight. And then after that, like because we built infrastructure for doing machine learning already way back when. And the crazy thing is that already then I was using Python and like working with machine learning engineers already back in 2000, early 2000s, 2010. I mean, people were really starting to use Python, and that, I mean, there were things like a NumPy was around, and like many like academic machine learning libraries, and of course like a Java was really the dominant language back in the day. But I mean, especially people coming from academia much preferred using Python. So then, like in 2011, I started a company, BitDeli, with my brother actually, where like we wanted to combine like many of these things that we started seeing emerging. One of them being machine learning, the second one being cloud, that you could do these things in the cloud, and the third one being this like amazing developer experience. So we built, actually, I'm still like really proud of the product that we built back then, where you could actually like do machine learning in the cloud, in the Python, in the browser, like back in 2011. And of course, I can tell you it's way too early. Nobody cared. Nobody cared about Python. Nobody cares about machine learning. Nobody cared about the cloud back then. We even did containers before Docker. Nobody cared. Nobody cared. And then like what the enterprise is, the only thing that they would have bought is like enterprise. Can you do this outside the cloud? And then I made the decision that, well, I think cloud is the future. I don't want to go that path, and then like ended up like getting acquired and so forth. But yeah, I think that like if there's any lesson like out of all these stories, that timing matters. It's always like it feels fancy of like having any kind of foresight. But I think there have been so many people in our industry even that are like, I mean, like if you look at the AI, there are many people who are kind of bitter that like, oh, I mean, like we have been doing this for a long time. And I know I used to work with people in academia who have been doing machine learning for a long time, and now they are really kind of pissed off like with all this like AI stuff that like it's kind of, we have been trying to do this like for the longest time. And then like the important thing is that at the same time everything today matters, and it's huge, and there is a qualitative shift. So
yeah, no, for sure. And it's, yeah, that definitely is a thing that matters in ML, right? That not only does the timing matter, but there's also like a component of this is somewhat cyclical. We do come back and recycle some of the ideas from earlier years sometimes, and you're like,
100%.
I was almost there. Why didn't you give me
Exactly.
money back then?
Yeah, that happens. Yeah. I mean, they're like people like way back when. I guess the term artificial intelligence was coined in 1950s, and yeah. So yeah, it is. But I mean, but the thing is, and like what's so important, and I have this principle for myself, is that 90% of everything sucks always. I mean, like whether it's like a people, companies, technologies, 90% sucks, but 10% doesn't. And it's so like easy to become cynical looking, and it's 90% is kind of almost everything. So it's so easy to become cynical by default that I mean, it's the same thing and we have tried this before. But then like the other point of view is that the 10% is like what actually advances things, and then it's the 10% that's kind of what matters at the end of the day. So we can focus on that.
Yeah, no, terrific. By the way, I do remember that I made an error in the introduction in that I forgot to mention your book. Somewhere here. This is a terrific book, and I really recommend it to anybody dealing with ML infrastructure, ML tooling. It is written through the lens of Metaflow, but every concept in there is applicable to anything that you're doing. And so in the midst of all the other stuff you've done, you've also taken 18 months, to write a technical book, which for those who don't know is not a thing somebody does to make money ever.
That's right.
But
And by the way, like it was probably written before LLMs of this nature. So I mean, it is all like produced by human beings. I guess these days, I mean, like writing a book is easy, so you just press a button. So
yeah, well, I actually just reviewed a book today that was written by an LLM, and yeah, it was not good. But
90% of everything. So
yeah, 90% of everything sucks, right? Yeah, no, and in that book, like I actually really love the concepts in it. I come from building some tooling for data scientists as well, and at one point you say, ultimately data science and ML are tools to be used by human beings, and I think we often forget that. I think often the first step of design in ML is to like figure out how you can use the new paper to do whatever. But in my experience, like a lot of the things that actually stick are things that were designed with a human in mind. And I know that this is a strength of yours, and obviously like it has been through both being a founder and being at Nokia, being at Netflix. And so how do you develop the understanding of the user? How do you get to the heart of the problem that they're actually having? In my experience, they won't tell you. Like they will tell you a lot of things, but not the real problem. So how do you elicit that?
Yeah. No, and actually, I think it's worse than that. That like, well, I mean, first, I think I very much believe that like if people would know what's the actual problem, they would solve it by themselves. So oftentimes, yeah, I mean, it's not that like people are somehow kind of keeping kind of the cards close to the chest or something, but it's really hard to articulate. It's really hard to know. So that's one thing. Now, I think that the second thing is that I'm a big believer that it's much about domain knowledge. I'm maybe I should run like a A/B experiment with myself and try to build something meaningful for some domain that I have no idea about, and I don't think that I would do very well. I think it's really, I mean, like if you look at any kind of craft, and this is not only about machine learning and not even only about software engineering, but like look at anyone. I mean, like you are like a musician or like kind of you are like a building whatever, like you are like a chef at the restaurant. I mean, it's always that you understand the domain, you have been doing it for a long time, and like you are really deeply immersed in that ecosystem. So I think that's really the key. And then I think with that, I mean, almost automatically comes the empathy, that you really have to put yourself in the shoes of the user. And it's not that like you necessarily, it's not like only technically understand that, oh, I mean, like this is what you want to do, but I mean really like a feeling as a human being. And the interesting thing, and like even like one of the guiding principles like for Metaflow is like all the technical stuff aside, is that actually so many times I saw that like a data scientist, machine learning engineers like were afraid, they were fearful of, let's say, breaking something or like pushing something to production that let's say wouldn't perform. And then like kind of nothing blocks experimentation and the creative mindset and the innovation as much as being afraid. And then like I think that the most amazing like experiences that I have had with any tools is that like when you feel that, oh, I can do whatever crazy and I won't break anything. And I think that that's, for instance, like one reason why people like things like Docker containers. It's such a kind of a such a kind of like a liberating feeling that I mean, I can slap whatever inside this Docker container and like presumably, I mean, it just stays in, maybe it crashes the container, but nothing else crashes. And I think that's one like an underappreciated aspect. But anyway, going back to the point that yes, I mean, like putting yourself in the shoes of the user, I mean, like not only technically, but I mean, like how would it feel? But I think it would be hard to do if you don't have the domain knowledge, if you kind of actually like haven't done the job. So I very much like would encourage anybody to really like kind of get deep into any field that happens to interest you.
But in the company as big as Netflix, I mean, Netflix is not that big, but it operates as a big company, right? Like
Right.
you couldn't go and say, "Hey, researcher, I'm going to go do your job for a month and figure this out." So how do you develop empathy? From a side, like you're still putting yourself in those shoes, but like you can't actually do that work.
Right. And yes, and of course, I mean, the idea is not to do the work. Especially the idea is not to think that like you could do the job better. I mean, of course, I mean that's the other part of like having a high degree of respect, that because it's kind of a thing that I believe, and it's most amazing to then like work with, let's say, machine learning people, data scientists who are super deep into some other domain that I don't know so much about, like let's say causal ML. I mean, like amazing, like researchers, like building like a causal models. It's a deep field of its own. I have like, I mean, like I'm afraid of causality, so that's hard stuff. But then like there's overlap, and then there are commonalities. I think again, I mean, like if this was some kind of a discrete topology, like where everybody would live in the universe of their own, yeah, life would be hard. But it is a fact that like even people working on causal ML, they oftentimes wake up and open a Jupyter notebook and they need to run some compute and they need to train some kind of a model or run some optimizer. And then I know that, okay, I understand what you are trying to do there. And yes, no, now like we are kind of a living in the world that I understand that. And that's the kind of a connection point. And then like when they say that, oh, I have this optimizer or I have this data frame with 100 gigs of data and like it crashes, it OOMs. So, okay, so then I can help you.
Yeah, I got to give it to you though. The book is probably one of the only books that I read that specifically mentions stand by name, because usually it's like, exactly, PyTorch, TensorFlow, and then everybody forgets that you can do non-deep learning ML as well. And for those of us who come from Bayesian backgrounds, like, oh yes, PyStan, yes, let's do this.
That's right. I mean, yeah, like kind of sending greetings to all the listeners. They're like, yes, doing that stuff.
Yeah, no, I appreciate the inclusivity of that. No, and that's terrific. Like, I understand empathy. I understand trying to like catch up, on the field and trying to understand what the real problems and there are. One of my big theses on this podcast is ML has a problem in that it's a rapidly evolving field. And people who are in demand are people who have like deep expertise, both because like we're able to empathize more with our customers if you're building tools, or but also like you're able to do newer and better stuff. But also like that it's not a field where you can learn the deep stuff once and then just live with that, right? Like
Right.
my undergraduate thesis was or sorry, my master's degree thesis was in something that involved uh, image recognition before CNNs were really a thing,
Right.
and so I became irrelevant pretty fast.
Right.
And so, how do you develop really deep expertise and maintain it over what like 2.5 decade career now
Right.
in a field that's moving that rapidly, where the paradigms change that fast?
Yeah, yeah, yeah. And well, I mean, of course, yeah. I mean, it's really not that like you go to whatever like a med school and then you become passionate about something for 3 years and then you call it a day and say that now I know everything. So yeah, I mean, that passion, that like a constant curiosity about the domain needs to be maintained, of course. And indeed, there have been many shifts. It's again, I mean, it's kind of interesting that I think like people oftentimes underestimate the fact that like yes, I mean things are changing. Also, there are some undercurrents that aren't changing so fast. So I always think that there are multiple layers. There are some foundational layers. Let's say like a linear algebra, like matrix multiplication. I mean, it's just been kind of the same. I mean, the algorithm, the first one's like maybe 100 years, and then the latest one's maybe 30 years, and so forth. So that foundation is exactly the same. So like let's say even if you went to school whatever like in 1990s and you learned about BLAS or like how to do highly efficient matrix multiplications, many of those things would be still highly relevant today, right? And then like on top of that, I mean like maybe you learn about backpropagation, and the backpropagation is kind of the same algorithm that it was already in 1980, so that's the same. But then like kind of yeah, like you to your point about let's say like a computer vision and stuff like that, then there are like things that you have to stay up to date, and like you have to realize that things are changing. And I do have to say that like one of the biggest fields that have really faced the massive changes, of course, NLP, and like anything natural language. And I mean just like because I used to be like in that field as well, and there were people like doing all the like things like a part of speech tagging and like kind of really fancy algorithms for like a summarization, and like if actually like all of that is kind of out of window now. And it's I mean you can try to make the case that like some of those things might be still relevant, but I mean of course it's kind of starting to get a bit tedious like with all the LLMs. So yeah, but I mean the key thing is that like it's not that like you have to start from scratch every morning. So but I mean yes, every day like something new.
So how do you go deep then? Like I understand. So like, okay, you have your base knowledge that you probably picked up when you were doing your undergraduate work or whatever, and then you have probably graduate work is a little bit more stuff that shifts because that tends to be at the edge of possible. You go into your first career, lots of people focus on tooling, and yeah, like you have to, right? Like you can't do your
Right.
job if you don't know the tooling. Uh, Plus, you have a job to do, and you know that this field is not very patient. It's possible that it's just the places that I've worked, but
Right.
I've never had a boss who said, this is due in 2 weeks. It's like always yesterday that it's,
Right. Right.
the company is on fire. We need to have it now. And on top of that, like, not only am I saying, like, not only are you saying like that you should be in step with the industry, but you should also like be able to go deep on at
Right.
least a few subjects. So how do you balance all of that?
Right. Well, well, I mean, now assuming that like most of us are like to a point in a situation that like you are not like maybe wealthy enough that you can just be an independent researcher and do whatever you want. But I mean, let's say you have to work for an employer, and then there are like definitely the business demands. So it's not so that like you can just say that okay, I'm taking 3 weeks to read these research papers. I I'm a big believer that like first I think it's always very beneficial to align your interest with the actual like business interests of your
Mm-hmm.
employer. Usually good things happen like when you do that. Usually bad things happen when you don't do that. And then well I mean it kind of implies that it is beneficial to the degree that you can choose to kind of but then like choose places where you feel that like you can like because it becomes easier to align your interests with the business problem. And an example here would be that like the company I founded back there in 2011, our largest customer was this company called Adderall that was doing targeted advertising. and actually, interestingly enough, they were like a largest customer that we had back then at my company. They were bigger than anybody else combined. And like when running the startup, I saw that these guys had absolutely like a shit ton of data, and also like the company was growing super fast, making a lot of money. And I was thinking about it then, and that like, wait a minute, I mean, there's a lot of data. They seem to be doing fine as a business. I mean, as many other technical people, I couldn't care less about advertising back then. I mean, like if anything, I mean, it kind of sounded a bit icky. But I thought that like, well, I mean, there are like aspects where like my interest can align with the business interests of this company. And then they ended up like acquiring us because they were like growing so big on the platform. And then it turned out that that was a great environment then to kind of both kind of produce a lot of value for the company. So they were hopefully happy, as well as then like be able to go deep and then like combine, like see that, okay, this is where the world is going. I mean, these are the latest techniques. And then like this is how we can actually apply them. And then this is the other important part that I very much believe, that like you have to learn with your hands. I mean, you can go only so far by reading the papers and reading the blog articles. I think that in so many cases it's so useful to just like get your hands dirty, and especially like when you have that external pressure, that there's kind of the business pressure that you have to deliver something. I mean, that also like helps you really to see what actually works and what doesn't. It's easy to kind of just like dabble with things and say that, oh, this is cute and that's cute. But I mean, then like when you have a time pressure and you have to deliver something and it doesn't work. So, and then sometimes the opposite happens and you realize, oh my gosh, this thing actually works.
Yeah, no, I think that's terrific. And I think that's the way that I've ever seen it working too, right? Like learning in the abstract is very hard in ML.
Right.
If you get your fingers on the keyboard, it becomes much easier. And I love the point about aligning with your employer's kind of goals as well. Um, Sometimes you have to sell your employer on the goals that you're trying to do.
Yeah.
And I'm not sure if that was the case with Metaflow, or if Netflix already saw that that was a problem. But all the stuff that you learned from the customer, from the empathy, from all your skills, like that doesn't mean much if you can't make a product out of it. And I know
Right.
lots of technical people who are brilliant, but for the life of them cannot figure out how to assemble all the pieces into a
Right.
product and how to then get the buy-in from important people. Can you
Right.
talk a little bit about that?
Yeah. Well, I mean, the first thing is also I do respect the fact that I think that there are many different valid goals that you can go after. I mean, one thing is that like you can be part of larger team and like you kind of do something and it's totally okay, like not to like want to get anything else out of it. And or it might be that like maybe just out of technical or scientific curiosity, whatever, you want to do different things. But again, I mean, it's totally fine if you don't want to take them anything beyond. I people come to me asking this question that, oh, I want to open source this thing, or like I want to build a community, or like I want to kind of start like leading my own project at the larger organization or whatever it might be. But and it is good to realize that it's not just that like you keep doing the same thing and somehow like you get the promotion and then like it's just you get like that you get to do the same thing, but I mean then it's just like everybody respects you and it's awesome. But also like it comes with many other responsibilities, and like it comes with compromises as well. And I think like oftentimes if you read Hacker News or like any other technical forums, the technical people oftentimes think that all this like a quote unquote politics is somehow like almost like an evil tax that's put upon us, and like somehow we are only supposed to be able to hack code and then like, and it's just kind of this evil plan that somehow other people like annoy us with this other thing. But I don't think that's quite true, and there are like very very valid reasons like why, let's say in a larger organizations, if you want to make a case that your little like a technical baby is worth anything, that then yes, you do have to convince people, and yes, people do have conflicting interests, and it's totally okay, and it's by design. And then that takes different type of effort, and like if you want to do that, that's awesome, but you also have to understand what you are signing up for. And then like, yeah, again, I mean, if you want to do that, I think that the first thing is absolutely to ask yourself the honest question that like, is there any kind of believable story that you can even tell yourself that this actually helps the company? And I'm actually like a big fan of this idea that you may have heard of in economics, like where you have this concept of like a principal agent dilemma, like where you have an employer and you have an employee, and oftentimes the employee's interests, rational interests, are different than the employer's. And like, let's say open sourcing something might be good for your career, it might be really beneficial to you, and it's actually counter beneficial. I mean, it's actually like really really doesn't help the company at all which is fine. And you then like you just understand that, okay, I'm operating within this framework and trying to kind of get the employer to accept something that's actually not good for them. Or then like you really like kind of then have to think hard that, okay, do these things actually align? And if they align, then it kind of becomes easier to tell that story, and then you can start navigating and making the case, and then oftentimes good things happen. And I think like in some cases, especially like technical people, they say that, okay, I really wanted to learn Rust. I implemented this thing in Rust, and now my boss says that, well, actually the company doesn't want you to keep writing Rust because the rest of the systems are written in Java. And then like if you kind of put your adult like a pants on, I mean, yeah, it kind of makes sense, and it's not like anybody else's fault.
Yeah, no, for sure. And I've been on those teams, right, where people were a little bit more relaxed about this. And you come in and you're like, oh, half of our stuff is in Haskell, a third is in Rust, and I'm like, I don't do most of those in production, you
Right.
know. So, yeah, so it's an interesting concept to align those interests, and I think a lot of you can only go so far without being involved in what like people deem politics,
Mm.
and you know you can go on your own, but you have to sell to VCs, or you can stay inside the company, but then you have to sell to VP or whatever. Like at the end of the day, there's a limited budget, and you need to justify your existence.
Yeah,
Uh,
no, I'm just like waiting until people realize that this will be happening with whatever AI agents you are building, because I think it's a like a inevitable result of any kind of game theoretic situation that you have these like independent entities and they have different goals and conflicting goals, and then they somehow need to negotiate that, okay, I mean, what is some decent compromise here? So
yeah,
it's,
yeah, yeah. No, it and that's an interesting world. I think we're further from that than I think most people think.
that's right, that's right,
But
100%. Yeah.
but I'm also a little bit more of a skeptic, you know. Yeah. So how do you compromise with yourself? So like I understand compromising with the company, but also from your deep empathy of like data scientists, for example, right? Like you have 100 problems,
Yeah.
but like you still have a limited team. You still have and you know maybe some of those problems are not as much as you can do beforehand. Like when the first version of your product is in the customer's hands, you learn so much more, and so you really have to narrow that scope down. How do you do that when you're like they're struggling, you know, like and when I was building infrastructure at Adobe, that was around 2015, 2016 timeframe, and people like had nothing, and so you're like, well, I need
Right.
to have a good data store, I need to have this, I need to have this, and it was really hard to like pare that down and be like, what is the thing that I can reasonably deliver now?
Right.
How do you deal with that?
Right, right. Well, I can tell you like example, like practical example from the early days of Metaflow. That now this was back in 2017, and some of you may remember that the whole like term MLOps didn't exist in 2017. And of course, I mean there were kind of a machine learning framework-ish things, but I think TensorFlow had come out 2015, but it was still pretty new. And even in the early days when I was at Netflix, I talked to some people. I mean, because really the context was that they also wanted to start like building new kind of a support infrastructure, like for like people using Python, doing different kind of machine learning things there. And then like I talked to people that, okay, what kind of infrastructure? And then like some people say that, okay, I mean, maybe we should have some kind of an interface, a class, like where we have like a train method and then the infer method and so forth. And it's of course like a perfectly rational, like a very understandable thought that, okay, I mean, sure, like interface, train and infer. But I mean, I had seen enough that, I mean, of course, the first like a head scratcher is that, well, you know, there are different kinds of models. Like a training can mean many different things, and especially like inference is the beast. So like, well, how should that infer behave? And like, you could imagine like having a design committee, and then like people start thinking that, wait a minute, but I mean, sometimes we need high scale inference, sometimes we need low latency inference, and sometimes it's inference with the logistic regression, sometimes with deep learning, and you get this scope creep that it needs to handle everything. Now, of course, like one thing is that you then prioritize and say that, okay, I mean, this is the only type of inference we support. But the other thing, like we did with Metaflow, is to really take a deep breath and like take a step back and acknowledge that, look, I mean, we have no idea what kind of models people want to use. We recognize that we have many type of inference scenarios, and we also like we are maybe like experienced enough engineers knowing that like there isn't like a one size fits all approach. There are many different use cases, And then we started thinking that, okay, but is there anything we can do that could help? And then like we started thinking that, well, I mean, people have this practical problem that in order to be able to even train anything, they need access to compute. They need to be able to, whether you use scikit-learn, like whether you used whatever Caffe2 back then, or like a TensorFlow, you need to get the box where you can train this thing. That can we at least make it easy for people to solve this mundane task of getting access to compute? And then, of course, one might roll eyes and say that, well, I mean, that's barely machine learning infrastructure, because, I mean, it's just like a facilitating access to compute. But I mean, we were humble enough to recognize that, okay, I mean, at least that's something we know how to do roughly, and that seems useful. And that's actually like what we did first. And then like we started releasing that like in a very humble manner to people who do this on a daily basis, and they were delighted. They were super happy. And then there's that, look, I mean, this is exactly the problem that I don't know how to do. I can call like a scikit-learn fit, and I know how to call like a TensorFlow, whatever, like a model optimizer. So, I mean, I don't even want to have some like a high-level abstraction that you are forcing on me. But I mean, like the fact that you solve this annoying thing that I couldn't do easily by myself, I mean, that's valuable. So I think that then that's why, I mean, like even challenging these like kind of a notion that, okay, what's even the problem that we are solving, and then having the humility of saying that, well, I mean, engineers especially are really good at overcomplicating things, and like the scope creep is inevitable, but saying that, okay, I mean, what is the kind of the simplest possible, the most foundational thing? So I think, I mean, at least for me, I mean, that seemed to work pretty well.
Yeah, no, terrific. And, you know, I know some researchers who were at Netflix at the time, and they were of very high opinion of the stuff you guys were rolling out. You did definitely solve problems that they had. I love the part in the book when you talk about incidental complexity. Like, we want to try not to introduce that because there's enough inherent complexity in machine
Right.
learning tasks. And you know, I think being humble is probably the best way to do that. To say, like, you know, there's, if I go too far, there's a chance that I'm going to introduce complexity that doesn't need to be in the system.
That's right.
I was actually wondering if you could talk a little bit about how you see that differentiation between, you know, what Andrej Karpathy would call coding 1.0 and
Yeah.
coding 2.0. So like traditional machine learning versus, or traditional software engineering rather, versus machine learning. Like what is different in those worlds?
Right, right. Yeah, no, that's really a fascinating question. And I think it will be actually like super relevant, like for the next couple of decades, as I think like most systems will have kind of a both. I mean, of course, there's like a school of thought that like maybe it will be all like at this quote unquote software 2.0, but I think it will be both. And now the way I see it, having built systems of both kinds, that in many ways, traditional software engineering, I mean, you can think that it's kind of like a continuum of a model complexity. And like, let's just say that like everything is a model, and like you have these software engineering models, and then you have like whatever, like a more like a statistically trained models, more like probabilistic models. And the thing about the software engineering models is that because they are so much manually crafted, they tend to be very simple. So in that sense, it's almost like a Newtonian like a physics, that like a pretty simple formulas. You understand the formulas, you can predict what happened, you understand the system, you can review the pull request, and like off you go. But then like when you keep going kind of onwards on that like a complexity spectrum, and you start working with these probabilistic systems, you are kind of entering this territory like where the models are getting more and more complex, and you can't first, I mean, you can't even comprehend like quite how it works. I mean, I challenge that like very few people even have good intuition how logistic regression works. I mean, like you can have a competition like between a data scientist doing a prediction versus a logistic regression, like given like 100-dimensional vector, and like, yeah, people always lose. And then it just becomes a bit of a like a qualitative change, that like how do you build systems that you don't understand. And the really the luxury that software engineers have is that you get to build systems that you do understand. Now, as the systems grow in complexity, and especially as you start having something like a distributed systems, then it starts like breaking down. I think what I find really fascinating is that, for instance, Netflix, I mean, just the traditional software engineering parts, nobody understands how the system, I mean, this is like a secret that I can tell you, that nobody understands how Netflix work. Nobody at Netflix. It's this amazing organism, like that different teams operate. And I'm sure that you used to work at Twitter, and maybe the same thing. Nobody understands how the whole thing, different teams kind of like look after different pieces, and then somehow like kind of things just work together. But it's a very biological system in that sense. But I mean, like in the small scale, modular scale, you understand what's going on. But then like kind of with these statistical systems, you don't have the luxury. And then the second thing is that the way how we build these systems is through data, and data is a massive source of entropy. And you don't understand the data, you can't have a simple explanation for your data. You just get this like a big blob of something, and then you put this big blob of something in this something that something happens. And that's just a very different way of building things than the software engineering. And I think that this is also like a source of much tension between the data science and machine learning and traditional software engineers, who then ask, and this is like why I have always had this issue with the term MLOps, because like, why isn't it just like a DevOps that like it's the same thing? Well, I mean, again, I mean, it's kind of same, kind of very different. And I think that really we have this article like kind of like a MLOps and DevOps data makes it different, and like it's really this idea that like having the complexity that you don't understand, having the entropy, that really like kind of makes it different to build the systems. Now going forward, I absolutely do think that it's highly beneficial to build systems that have both elements, that you have both parts that you do understand, and you have both parts that like can encapsulate the real world complexity that you couldn't put in if conditionals, that you kind of need both. And I'm sure that like if I take a Waymo self-driving car here, I don't want it to be so that nobody understands how anything works in that car. I'm pretty sure that it's a combination of traditional software engineering, and it's a combination of like, let's say, computer vision working on deep learning. And I think that's a good like a balance, match made in heaven, like kind of some systems we understand, some parts that we understand less so, and then it all works nicely together. And I think that's the future.
I spent so much of my career fighting for that like, especially recently, there's been a push toward end-to-end machine learning. And I'm like, if you can write an if statement, it should not be an ML model.
Yeah, that's right.
It's interesting. I talked to a former colleague of yours, David, a few years back, and I was really proud at the time. I had like a really high unit test coverage. And I was like, look, like I have really high unit test coverage. And he's like, that's great if your problems are unit test problems, but most of my problems are integration test problems. And I was like, oh, mine too. And,
Yeah.
and I haven't thought of that before in those terms, but yeah, I mean, there's the integration then between those systems also becomes quite difficult, right? Because if you have something that you can understand fully and something where there's like a little monkey pulling on things,
that's right.
That becomes
yeah
quite hard. Yeah, and it's interesting to explain to the higher ups too. Is well, why didn't it work this time?
That's
it
right.
works 99.9% of the time.
Yeah. And I do think that also like it poses a really an interesting question of like how do you lead, how do you manage then like the data science machine learning teams? Because of course one point of view is that like you are working with this absolutely like unpredictable like a wild donkeys, kind of not the data scientists but the whatever systems they're working on, and then it's totally unpredictable. But that is a very unsatisfactory answer as a business. And I have to say that now as a CEO, if somebody comes to me saying that, oh, I like my team, like we can't commit to anything and like we can't promise anything, you just keep paying us actually more than anyone else, I'm kind of scratching my head that like, wait a minute, who's the fool here? So I think also like a really interesting question is that like given all that unpredictability, stochasticity, how do you then like still like manage to continuously produce value? And I think that's absolutely like one of the key questions in our industry.
So how do you, or rather, how have you've worked with a lot of people over the years. You've worked with some of the best people over the years. So let's, 90-10, take the 10% of the best people that you worked with, and specifically in ML. And what are the things that they do that make it easier for them to tame the donkey, I guess, or like maybe the way that they look at it that makes it a little bit easier? This is kind of the central question of this podcast, really, is what makes a good machine learning engineer? And I think I feel strongly enough about not being able to answer it in one sentence that, I think this is going to go on for years. But what makes the best ML engineers or ML ops engineers, anybody who works in this system?
Right. Well, I mean, first, I do want to like caveat my answer by saying that if you ask me that like what makes a good software engineer, I think it's fair to say that the field is big enough that I don't think there's necessarily one answer. I mean, there's always this like a mythical like a 10x engineer. Like you could ask that what is the 10x MLOps engineer, like a ML engineer. And I think going back to what we discussed earlier about aligning yourself with the business value, I think by necessity the answer has to be a bit contextual. that I mean, I have seen cases where you have had amazing individuals, and there isn't just like a fit between the organization and the individuals. So that's why I mean, it's always like I don't think there's necessarily like one size fits all, and there are just like a different situations like require different type of skills. But I know that that's always boring answer. I think like one thing overall, like as a human trait that oftentimes like goes across people is definitely, of course, like a really really deep curiosity. I mean, I think it's kind of maybe a bit like an unsatisfactory answer, but all the best people, I mean, they have really really like deeply cared about the craft, and even so much that like it is definitely for them it's way more than just a job. I guess it goes like to everything, and also like they are definitely like always always like unsatisfied with the status quo, like always like a pushing things, but also like kind of a keeping very much in mind, like again, I mean, the business goals. So because I think like also like I mean, now like the one thing like having that like a business goal in mind is that it's not only that like somehow you are supposed to make money for your employer, but it also like it gives you a goal. I mean, it's like it's just like optimization goal, almost like for a machine learning system, that like you are like optimizing against some y, and that y can be arbitrary, but at least you have a goal, and then you understand that, and then you consistently work towards it. And like also like oftentimes the best people, they're actually like a pretty good at like a staying, keeping consistent, like working towards the goal, like also like having enough energy to kind of keep doing it. And then I do have to say that again, I mean, maybe a bit boring answer, but I mean like having a strong kind of a foundational skills definitely helps. I mean, that's why I would definitely recommend anybody, even today in this world of whatever ChatGPT is, to really kind of spend some time like learning a strong foundation, like both on the software engineering side, as well as then like kind of a whatever domain of science you are interested in. I think that it just happens to be a strange coincidence that like all the best people, I mean, do tend to have that.
Yeah, no, that's definitely great, and I love your nuanced point. Actually, like I love boring answers. That's totally fine with me. I might, there might never be any listeners to this podcast because of that, but hopefully,
Yeah.
anybody who's made it this far, you're exceptional.
Yeah.
But
Probably
I,
only boring people at this time.
but but honestly, I think there's sometimes that is the answer. Sometimes the answer is that it is situation dependent, and I'm wondering if you can elaborate on maybe like a couple of different situations here, having worked in different spaces. So you've been in academia, you've been in companies that were tremendously under resourced, and you've been in companies that were resourced really well. So maybe between those, like what is like what would be a good quality for somebody to have in like the under resourced environment that maybe is not that good of a quality in the resourced environment, or vice versa, whichever one is easier to come up
Right.
with.
Well, I think, I mean, like looking at that dimension, I think the big difference there is that, like, let's say if we say that any smaller company under resourced company, like it typically has fewer people by definition. So then, like, definitely having more generalist skills is helpful. So let's say you're an MLE, like working at the startup, the fact that like you know SQL, you can be a bit of a data engineer at times. The fact that you know a bit more about infrastructure, maybe you can set up an AWS account, that is helpful. And the fact that like you can be dangerous enough, like with machine learning. So, but then like let's say you are at Netflix. I mean, it is a fact that like you don't have to be a data engineer, at least not in the same sense. And like, yeah, most definitely you don't need to set up your AWS accounts. And so, I mean, it definitely does afford a bit more specialization in that type of environment. But again, I mean, that goes to say that that's why, I mean, the being creative is so situational, that like I have worked with some amazing generalist people who probably wouldn't have done so well at Netflix because they are maybe a bit too broad for that environment, and then like maybe vice versa as well.
Yeah, no, for sure. And there are many other dimensions that I could ask you about. Like Nokia was obviously the hardware company, which is completely
Right.
different. But if I did, we'd be on this for way too long.
Yeah.
In all of those, though, like you're never working in isolation. You always have to work collaboratively. And I think to me, at least, one of the differences with ML is that our systems are so complex that a software engineer would have an easier time just like going and building something and then bringing it to the product manager, and then they never talk to anybody else. Most projects that I've had, I had to talk to UI UX, I had to talk to like product engineering, I had to talk like across multiple schemes. And I usually ask this question very broad of people who've been in your situation, but you are kind of a unique case where you understand the connection between production and research really well. And so I was wondering if you can talk specifically to what have you found to be the best practices to interface there, right, with the people whose goal is, I think at Netflix you called them data scientists, at Adobe we
Mm,
called them researcher, but their goal is not really to make the company money. I mean,
right.
not directly. And your goal as an engineer is. So how does that interface work?
Yeah. Yeah. Well, I mean, again, yeah, I mean, there are definitely like different expectations uh, for for uh, for like different people. I mean, like you can call them data scientists or machine learning engineers, and I unfortunately seen mismatches where there was a person who was expecting that they were hired so that they can do amazing research, and like were hoping to do amazing research, and then the company really wanted them to deliver like a pretty mundane business value. And then like also like the other way around, that like sometimes the company like wanted to push bleeding edge research. I used to work at Nokia Research, where actually like I was perversely in another situation that like I got bad feedback for doing things that were too practical. And I actually like back then I didn't quite understand how that works, but now I'm actually like understand a bit better the dynamics, like what they wanted to get out of that organization. um I think I'm actually still like very much of a proponent of the idea that even in a research situation, it is beneficial to have constraints. And I think that this is the thing goes with any kind of creative endeavor, that like having constraints is actually it is very much like an innovation inducing. And I mean, oftentimes I have worked with people, let's say, coming from academia, maybe have some kind of a ideal notion of the academic freedom, that like, well, I mean, yeah, no, I mean, this is research, I can't promise anything, I can't even say what kind of things I might be, what kind of papers I might look at, or what kind of models I use. And it's a total like I mean, it's like a renaissance person doing whatever I want. And the thing is that like it's not even the employer like wanting to somehow like make money, but it's also that I don't think that that even leads to best results, even for that person. I think it, like for anyone like who has that like intellectual capacity and desire, it's really fun to know that I'm working towards the goal. And I really do believe that like all the best things come out in those environments. And it's actually like, unfortunately, even although it's not fun, even having some time pressure, it definitely does help. I mean, many people who have been working as a grad student, like working on a PhD, I mean, like, yeah, I mean, if you have infinite time, I mean, it's kind of hard to get motivated to kind of get stuff done. So yeah, having constraints is still useful. And yeah, I mean, some of the best things and most exciting things that I have seen then have happened in an environment where there are like a definitely business expectations and even time pressure and constraints. But then like well, the understanding, I think like what comes with that is that there's, especially the leadership needs to in those kind of situations understand that the results are uncertain, and it's possible that like nothing comes out of it. And I think that that's the main thing, that it's totally okay to fail. And they're like the best antidote to that is to then like make sure that at least like we can keep the iterations reasonably fast. And I think it's even like for more like researchy type of things, it is a fair assumption that like at least like we can run some kind of like experiments at reasonable speed. And then like typically the idea is that then like out of that certain kind of a bit like a directed Brownian motion, you started getting some inklings that like, is there anything here that like might produce value? And even if you think of now, let's say the early days of like whatever LLMs, and like if you think of something like a GPT-1 or GPT-2, and like by today's standards, like really crappy models, but I mean definitely showed enough value that like it motivated people that like, okay, let's keep working on this, I mean we might be onto something. And then like you can actually even start like a pouring like more resources on it. So I mean, even like hence like for those like research minded people, definitely yes, I mean like invite welcome constraints, like welcome even time pressure. And then like, yeah, I mean still like have the mindset that like even in a like a research environment, like we can scope things so that like we can start like getting the early signs if we are onto something or not.
Yeah, and I think that's actually where infra really comes in, right? Is like keeping that cycle
Right.
manageable, and because the
Yeah,
only
yeah.
way that I ever figured it out is like stuff has to be automated. If you're doing
That's right.
bespoke thing every time,
I
it's going to
yeah,
take
no,
too
I
long.
think that's a really good point, and I think one thing that's really really important is that like really I guess one has to be super like clear minded that like what is the thing like where like we are contributing most value. And I do, I mean, I'm still like so surprised that like in many places people feel that, oh, I mean, it's totally fine for us to spend a lot of time on like setting up the AWS accounts, or like spending a lot of time hacking like whatever like a software abstractions that are actually like not relevant like for the kind of whatever like a research thing you are working on. So yeah, I mean, getting the foundations, I mean, of course, I mean, this is the place for me to kind of promote Metaflow, that yes, I mean, you want to get access to data, you want to get access to compute, you want to orchestrate multiple steps, you want to get the versioning, you want to get all those pieces right, and then like you can focus on like doing the kind of the fun part.
Yeah, no, for sure. And Metaflow is a terrific product that it needs to be promoted. So I have no problem with that whatsoever.
I appreciate.
I do have kind of one more meta question for you, if you'd like. So assume you can't predict the future. I know you have a couple of times in your career, but assume you can't. Uh, and you see like a young person that you particularly care about, who's like really want to be an ML engineer, and like I'm going into this now. What would be your bit of advice? Like, you don't know which technologies they're going to be working on, you don't know which area of ML they're going to be working on, but they are going into this chaotic industry. They're going to have a 30-year career. My assumption is AGI is not going to take over by then to
No,
like completely
no,
eliminate all jobs.
no.
So what can you tell them to kind of get them on the right path today?
Yeah, yeah, yeah. Well, I mean, first, I would say that take a deep breath. I don't think. I mean, good working assumption is even to be a bit contrarian. That although everybody keeps telling you that things are moving so fast, and oh my gosh, like 2023, like you were supposed to learn vector DBs, and 2024 it was supposed to be RAG, and now you're supposed to be agentic AI, and oh my gosh, I mean, this thing is moving so fast. Maybe it isn't, and maybe much of that is just noise, and like maybe there is something more foundational, more fundamental that actually matters. So I mean, definitely would like everybody to really like a focus on these things that have been stable. I'm actually like a big believer in this like a Lindy law, that whatever like it is, if like kind of however many years it has existed, I mean, a good expectation is that it will be the equal, it will continue existing the equal number of years in the future. So let's say something as mundane as let's say Linux, it has been now around like for about like a 30 years or something like that. So I think there's a really good expected values that Linux will be around for another 30 years. I mean, maybe Unix, I mean, has been around for 50 years, will be around for another 50 years, and so forth. So if I had to think that, okay, I mean, like what to focus on, like a kind of, well, I mean, I don't think that those things will disappear. So that would be a good foundation. And like many of the things that people may look like that they are like so novel and so new, again, I mean, like a big portion of things that are new are actually built on top of existing like a building blocks. And even like you look at the machine learning stacks and like what actually like makes these things stick under the hood, there are layers upon layers of really solid and robust and kind of like old technology. I mean, even if you like start tearing the layers of PyTorch, and then like you find like things like NumPy that has been around for 20 years. So then like if you're a young person, like let's say you want to get employed at Meta to work on PyTorch, I mean, they're like 80% of it is actually something that like you can learn. I mean, it's not that new and you are really far. And then 20% is really the bleeding edge research, like what are the latest optimizers, like whatever is the latest activation function that happens to work and so forth. But you can get far by learning the
I think
fundamentals.
Blass and Lepak are still in there, right? And they're
Exactly. Exactly.
and I don't think anybody is ever going to be crazy enough to rewrite those two libraries.
Exactly.
It's yeah, no, and uh, I think it's a good reminder of like taking a step back. First of all, I think is a good reminder just in general, because um, when embeddings first came out, that was huge, but I don't think that ML accelerates like you would believe if you were reading like Twitter. And I think it's more of steps. Like,
Oh,
there is a step when we learned about backpropagation, and then you can't go back from that. That's it. There's a step when we got embeddings, and like I don't think embeddings are like the final data representation, but boy, like compared to a bag of words and everything we used before then, the amount of semantic uh, meaning that you can get from embeddings is so much higher.
Right.
And so, like AGI is coming at some point, and there are a
Yeah.
few of those steps that need to happen, but they're research steps. And to your earlier points, like I don't know when they're going to happen, and it's probably not super useful to predict.
Right.
Uh,
And I
but
guess like people also like get confused about the time ranges that like when we say fast, I mean there's the Twitter type fast that like, oh my gosh, I haven't checked my whatever stream like for 2 hours and now there are like a 50 more messages, but that's not actually like how technology develops. And even things that are kind of fast, like let's like use your example of embeddings. Now I don't know, like embeddings have been kind of mainstream now for about, I don't know, like 8 years, 9 years, maybe 10 years. So like in terms of one's career, like even if you were kind of a, I don't know, like a 3 years quote unquote late for embedding, still you would have 7 years to learn them and still like you would be very much up to date. So I think that, and I think a big problem with many people is, and this is the saddest thing ever, and like if there's a one takeaway is that like people think that they are not even starting to learn because they think it's too late, and it's never never too late. And even today, like kind of a, I mean, like you want to learn logistic regression, I can guarantee, and this is the most contrarian thing to say, that if you are learning logistic regression today, you are not late, and it will be surprisingly valuable even 15 years like from now. And of course the same applies with everything else. So and the worst thing you can do is to not to learn anything because you think you are too late for everything. So I mean, like starting somewhere, like starting with things that have been around, and like actually quite soon, like you will be surprised, like how you learn more than how you know more than 80% of people on LinkedIn, and then you are kind of at the point that 90% of everything sucks, and then you get to focus on the 10%.
yeah, for sure. Yeah, and honestly, I've been doing this professionally for 14 years. Every time I go to LinkedIn, I'm like, how do they know so much more than me? And then
Right.
you sometimes realize that maybe that's a little bit more of a facade than
Right. That's right.
it should have been. But I would love to keep you here for another 2 hours, but unfortunately, I can't. So, uh, there's obviously lots more that you can share, and I'm just wondering, like, if anybody is listening to this who wants to find out more about you, about Metaflow, about Outer Bounds, how do they get in touch with you? How do they keep up to date with what you're doing? Um, what should they know? Where should they go?
Yeah, yeah. Well, I mean, since you mentioned LinkedIn, and yeah, no, I mean, definitely. I mean, that's a good place to start. Like, so yeah, I mean, definitely happy to connect there. Well, I mean, kind of of course, I run a company, decently visible, outerbounds.com. Now, I also like, do you want to invite absolutely like everybody, all the listeners here, to join the Metaflow community? So you can go to metaflow.org. There's a button to join the Slack community. There are thousands of people. Like, and I have to say that like one of the most coolest thing about that community is that there are many interesting companies like working on all kinds of real world problems, some like more futuristic, some like powering the world today. So I mean, just as a place to see like what the MLEs are actually working on, and you will be surprised that like many of the problems are actually quite mundane. I mean, it's just a good reality check. So if you are part of both the Metaflow community and LinkedIn, I mean, you kind of get to see the kind of the absolutely kind of a hallucinating kind of some kind of a like a fever dream of a future, and then the actual like a reality what happens today. And I think it's very healthy to see both.
Well, terrific. Thank you so much for coming on. And yeah, I hope lots of people come join the Metaflow community, and I hope they learn a lot more. And yeah, I can speak to several people in Outer Bounds that I interacted with. I think you guys got top notch talent, and definitely would love to see you grow and continue to spread the message, because that's the other thing that I love about you guys is that you're very open about things that you're learning, and there's a lot to learn from you. Thank you.
Thank you. Thanks for having me.